The point P10 lies on the curve y equals sine 10 pi divided by x. If Q is the point x, comma sine 10 pi divided by x, find the slope of the secant line from P to Q for x equals 2, comma 1.5, 1.4, 1.3, 1.2, 1.1, 0.5, 0.6, 0.7, 0.8, and 0.9. Do the slopes appear to be approaching a limit? Alright, so let's take a look at this example. Alright, first thing we need to know is that this is our slope of a secant line. So P to Q, slope of the secant line. Here's our equation. Our equation is the rise over the run. So rise, remember that's how you find your slope, rise over run. And now we need to know, what we need to know is where our variables are coming from. So we have px, py. So that's the point px, which is going to be 1, and the point py, which is going to be 0. And the qy, qx. So we're given that the point q is x, and we're given that the point q is the function of y. So all we need to do is plug in numbers for y. So let's head down over here. So we know that p is 0, so this is the abbreviated version of this equation over here, the point slope of equation, right? So now all we need to do is write what's on the bottom. This is our initial point, P. So this is what we're going to use for all the problems. So we have 1, 1, 1, 1, okay. Now all we have to do is plug in for x, for q. So the 2 gets plugged into this point q. So 2 minus 1, that becomes 1. And now we plug in 2 for the function. So sine 10 pi divided by 2, which equals sine 5 pi, which just equals 0. And so now we do our computation for the rest of these numbers. And the numbers are as following: 1.7320, 1.0847, negative 2.7432, and 4.3301. Alright, so now we gotta do the rest of these. We had 6 more. We gotta solve for the rest of these x's. So this is the abbreviated version, the reduced version of our point slope form. And we plug in our x, where x is our 1.1 to this function. All these functions down here. We get this computation, so we compute it. And we end up getting negative 2.8173, 0, negative 2.1651, negative 2.6061, negative 5, and 3.4202. And so the initial question was, do the slopes appear to be approaching a limit? And so we're going to have something that looks like this. It's going to say limit q to p MPQ and equals the slope. And this is to find the slope, right? M stands for the slope, capital M, of the tangent line. And I'll just put 10. Alright, so now it says use a graph of the curve to explain why the slopes of the secant lines in part A are not close to the slope of the tangent line at P, the Desmos. And if you guys don't know what Desmos is, I'll leave it down in the description. So I plugged into the Desmos calculator. It's a free calculator online. And this is what the curve looks like. And so this is our point P. And now I want you to take a look at this. This is our curve. And our P's right here. And so if you were to try to find the slopes of the secant line, which is this what the question is asking, it's saying use a graph of the curve to explain why the slopes of the secant line in part A are not close to the slope of the tangent line at P. And the question is asking like why. And if you were to take a look at your slopes of the secant lines, let's say for the first part it says x equals 2. So I'm going to use this color for our Q. So this is the slope of the secant line, Q. And it's going to be on x equals 2. This is x equals 2. So x equals 2. If we were to draw it on here, so this is a bigger visualization. So this is 1, this is 2. So it's going to be right here. And where is that secant line going to go through? It's going to go all the way over here. Let's see, 1, this is 2. And we're going to have something that looks like this. This is the line going straight through it. And so the question is asking, using a graph of the curve, to explain why the slopes of the secant lines in part A are not close to the slope of the tangent line at P. And you can see tangent line P is right here. And you could tell why the slopes of the secant line aren't close to the tangent line at P. It's because of how spread apart they are because of the curve. And so in order to answer this question, we gotta say that the slopes of the secant lines are not close to P because of how stretched out the curve is towards the y-axis. And that's basically all you have to say. I mean, you could say something else too. And so let me put another slope of the secant line. So let's say we had something like this. We might have, like, even if I draw something here, it would be outrageous. So like, we might have a point like this somewhere here and somewhere over here. It might stretch out over there. And so these secant lines are going, you can't even tell where they're going actually. So I mean, it's kind of hard to determine where the limit's going because of how these secant lines are everywhere in our curve. Of course, that there is a limit right here. It seems like it converges at 0, P, and the point P is given. So I mean, it says P equals 1, 0. So we know that P is 1, 0. So we know that it does converge. It's kind of hard to tell because the numbers might have like a number over here that's point something, and our secant line is going everywhere. Alright, so let me reiterate what I've been trying to tell you. The slope of the secant line are not close to P because of how stretched out the curve is towards the y-axis. And so there could be another sufficient answer for this question, but I believe that is sufficient enough for this question. Thank you everyone. If you enjoyed this video, it would help a lot if you would subscribe to my channel and if you would like this video. If you want to see more content like this, it would help a lot if you subscribe. It allows me to keep making content like this for you guys. If you have any questions or ideas for the future, please leave a comment down below. Thank you once again, and I can't wait to see you all next time.